So in this last problem, we're going to do this one more time. We have a conic section represented by the equation r equals 6 over 4 plus 2 cosine theta. And we are going to look at all of its key characteristics and write its equation in standard form using x and y. The textbook does an example that's really similar to this on page 990 of your text if you want to follow along and see another example in your book. Check out page 990. All right, so we got to start with the eccentricity. Remember that the parent equation, the general form, is EP over 1 plus E cosine theta. The key here to remember is that the parent has a 1 in it. This equation does not start with 1. It starts with a 4. So what we're going to do is we're going to take this equation that starts with a 4, and we're going to force it to start with a 1 by dividing through by 4. We're going to divide the denominator by 4, and we're also going to divide the numerator by 4. So that makes the equation 6/4 over 1 plus 2/4 cosine theta. And you can simplify if you wish. R equals 3/2 over 1 plus 1/2 cosine theta. So you're always going to have to do that if the denominator starts with a number that's not 1. So now that that's simplified, we can see the eccentricity. The eccentricity is the value in front of cosine. So the eccentricity here is 1/2. And that tells me that I'm dealing with an ellipse because that's a value less than 1. So I have an ellipse. I can tell that it's horizontal because it's cosine. And because of the plus sign, my directrix is above the pole. So if I want to sketch a quick graph, here's my pole. My directrix is above the pole. Oh, excuse me, it's cosine. My ellipse is horizontal, which means my directrix is vertical, so not above. It's going to be to the right. And there's my ellipse. My directrix is to the right plus cosine. Cosine's in the x direction. So positive, I go in the positive x direction to get to my directrix. So my ellipse looks something like that. And I need to change not above. My directrix is to the right of the pole. Okay, so now I need to think about my vertices. My vertices are on the horizontal axis. So if I think about my unit circle, what two angles are on the horizontal axis? Those angles are 0 and pi. So I'm going to substitute those two angles into the equation. So my equation is r equals 3/2 over 1 plus 1/2 cosine theta. And to be on the horizontal, theta could be 0 or pi. So let's start with 0. 3/2 over 1 plus 1/2 cosine 0. Using my unit circle, the cosine of 0 is 1. So this is 3/2 over 1 plus 1/2. 1 plus 1/2 is 3/2, so 3/2 over 3/2 is 1. That means that I have a vertex at 1, 0. Now let's find the other vertex, this one over here. That is at angle theta, so r equals 3/2 over 1 plus 1/2 cosine theta. Again, using my unit circle, I find that the cosine of theta is -1. So 3/2 over 1 plus 1/2 times -1. So 3/2 over 1 minus 1/2, which is 3/2 over 1/2, which is 3. So my other vertex in polar coordinates is at 3 pi. So my two coordinates in polar, let me write that that's polar. The polar vertices are at 1, 0, where 0 is theta, and 3 pi. If I convert that into rectangular coordinates, here's a polar graph. 1, 0 means you go to 0 theta, you go out 1. 3 pi means you go to angle pi, which is over here, and you go out 3 units. That's 3 pi. So in relation to 0, 0, in xy coordinates, this point's still at 1, 0. This point over here is at -3, 0, because it's 3 units away from the pole. So those are my vertices, 1, 0, and -3, 0 in xy coordinates. My center is halfway in between those 2 points. I can average them together, and I find that my center is at -1, 0. A is your distance from your center to your vertices, and -1 is 2 units away from +1 and from -3, so A is 2. I can figure out C because I already know the eccentricity. If I go back to my original equation, my eccentricity is 1/2, and my old definition is C over A, and I just figured out that A is 2. So that tells me that C is 1. And then I can find B because in an ellipse, the formula for B is a squared minus b squared equals c squared. I just figured out that A is 2, and I figured out that C is 1. So B is the square root of 3. So the last thing I have to do is to write the equation for this ellipse. And it's centered at -1, 0. A is 2, and B is radical 3. And it's a horizontal ellipse. So my numerators are going to be x plus 1 squared and y squared. That gives me my center at -1, 0. Because it's horizontal, A will go with the x, so a squared will be 4, which means that b squared goes with y. And that's my equation for this ellipse.